Okay, hopefully I can get this finished now. I'm still going to do it in 2 more parts though, because it makes the processing of the video a little faster, but hopefully I won't get interrupted again, and I can actually finish this soon. All right, so what I was saying about synthetic division is that you do need to know how to do synthetic division. It is on the test tomorrow. However, we have not done one yet where the leading coefficient or the coefficient in front of x is not 1. You have done it before. You did it in Algebra 2. It's a review. You need to know how to do it. So I'm going to go ahead and do this example for you. And then on the test, just know that it won't show up like this, but you still do need to know how to do it. All right, so in order for this to be 1, I'm going to have to divide everything by 2. But by everything, I mean everything. So that changes this to x cubed minus 2x squared plus 3x plus 6 divided by x plus 1/2. Okay? So I'm going to test the negative, or I'm not going to test it, but I'm going to do synthetic division with the negative 1/2. My coefficients are 1, negative 2, 3, and 6. Remember to use placeholders for any zeros. We don't have them here, but that's important if I have them. So bring down my 1, negative 1/2 times 1 is negative 1/2. Negative 2 plus a negative 1/2 is going to be a negative 5/2. I'm going to multiply negative 1/2 times a negative 5/2. I'm going to get a positive 5/4. Then 3 plus a positive 5/4 is going to give me 17/4. And then when I multiply 17/4 times a negative 1/2, it's going to give me a negative 17/8. Right? Then 6 minus 17/8 is like 48/8 minus 17/8. So that'll give me 31/8 as my remainder. So this is what I end up with then. This was a cubic, so this is now my squared term. So I end up with x squared minus 5/2 x plus 17/4 plus 31 over 8 over x plus 1/2. But we can't have a fraction in a fraction there. And so when you divide by fractions, you multiply by the reciprocal. So I pretend like this is over 1, flip and multiply. So really all that happens is the 8 ends up coming down here. But it's not anything magic. There is a mathematical basis for that. So that means I'm going to get x squared. Let me just take care of this part right here first, so I don't have to rewrite that a bunch. So that's going to give me 31 over 8 times x plus 1/2. And then I can distribute that 8 in there. So this will give me x squared minus 5/2 x plus 17/4 plus 31 over 8x plus 4. There is my final answer from the synthetic division. All right, next page. I'm going to use synthetic division to find f of negative 3 for the function. So technically, this is called synthetic substitution when you do that, but it's still basically what synthetic division looks like. So we're using negative 3, and then I've got my coefficients of 1, negative 2, negative 1, and negative 10. Okay. Here's my remainder. So bring down my 1. It's negative 3 times 1 is negative 3. That's negative 5. Negative 3 times negative 5 is a positive 15. That gives me 14. 3 times 14 is 42, but that's a negative 42. So end up with a negative 52. So, and this is why I kept having you say, write down what it means that it is the remainder. Since there is a remainder, then x plus 3 is not a factor, but that's not what it was asking you for here. Anyway, it says use synthetic division to find f of negative 3. So when I do this, there's my answer right there. F of negative 3 equals negative 52. All right, so now we're going to test to see if x plus 3 is a factor of this polynomial using synthetic division. So if I'm going to use, if it's x plus 3, I've got negative 3 again. Coefficients here, I've got 3, 8. There is no x term, so I have to use a 0 there, and then 9. Don't forget about your placeholders. So bring down my 3. Negative 3 times 3 is a negative 9, so this is a negative 1. Negative 3 times negative 1 is 3, so that makes this 3. And then negative 3 times 3 is a negative 9, so this is 0. So this is what this tells me. My remainder is 0. Right? Here my remainder was a negative 52. My remainder is 0, which means f of negative 3 equals 0, which also means that x plus 3 is a factor. Make sure you understand what it is that you get, and not just that you can do synthetic division, but why are you doing it, what is it telling you, so forth. Okay, so then it says, given one factor, find all the remaining factors, and then factor completely. Doesn't tell you how you have to do it, so you could do long division here, but I really think that we probably all prefer synthetic division when we can do that. A lot less writing. Plus, I don't have that much room, so that's what I'm going to do. So if this is x plus 4, it's going to be a negative 4. So I have a 2, and a 9, and a 1, and a negative 12. Okay, and let's think about this too. It's not saying, is x plus 4 a factor? Okay, here we were testing. So the answer could have been no, and we could have gotten something other than 0. It's telling me it's a factor here. So my remainder darn well better be 0, and if it's not, I did something wrong somewhere. So I bring my 2 down. Negative 4 times 2 is a negative 8. 1, negative 4 times 1 is a negative 4. Negative 3. Negative 4 times a negative 3 is 12, so we get 0, which shouldn't be a surprise. That's a good thing, but it's not like we could have just skipped it since we know it's 0, because this is what we're trying to get out of it. Since this was cubed, then this gives me my x squared term. So now what I have is f of x equals x plus 4 times 2x squared plus x minus 3. So I'm supposed to find the remaining factors and factor completely. So I'm going to need to factor this, so I'll come off to the side over here and do that. So I need 2 times a negative 3 is a negative 6. So two numbers that are multiplied to give me negative 6. Signs will have to be different, and they got to combine to give me x. So that means I'll use 2x squared, then plus 3x minus 2x minus 3. Always make sure at every point, if I add this back together, I get that, so you're not doing something ridiculous when you know how to factor. So I'm going to factor by grouping here. This is going to give me x times 2x plus 3. Then I got to factor out a negative 1 here, and that's going to give me 2x plus 3 there also. So this becomes 2x plus 3 times x minus 1. So when I plug that back in over here, it's going to give me f of x equals x plus 4 times 2x plus 3 times x minus 1. Okay, so this factor completely. There it is. It is factored completely. And I need to find the, well, find the remaining factors. Oh, I just had to factor it completely, so I didn't have to write the solutions necessarily. Didn't ask for that. All right, rational root theorem on the next one. Let's list all of the possible factors. So remember, we need to make fractions out of these factors over these factors. So that means for 8, it could be a 1, 2, 4, or 8. For 6, it could be 1, 2, 3, and 6. So there's going to be a lot of them. Remember, you need the plus and minus of all of them. So I will start with all the whole numbers. So 1 over 1 gives me plus or minus 1. 2 over 1, plus or minus 2. So then that's also plus or minus 4, and plus or minus 8. Okay, so then I'm going to go back. I've already done 2 over 1. If I do 2 over, oh, I'm sorry, let me start with the 1. I did 1 over 1, so now I do 1 over 2. So plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Now I go to the 2. I've already done 2 over 1, that's 2. 2 over 2 is 1. 2 over 3 I do not have, so plus or minus 2/3. Then 2 over 6 reduces to 1/3, which I already have. So then I move on to 4. I've already done 4 over 1. 4 over 2 is 2. I got that one. I do not have 4 over 3, so plus or minus 4/3. 4 over 6 reduces to 2/3, and I do have that, so I don't need that one. So then I move on to 8. I have 8 over 1. I have 8 over 2, that's 4. 8 over 3 I do not have, so plus or minus 8/3. 8 over 6 reduces to 4/3, which I already have, so I am done. Remember, make sure you have a methodical way to go through it so you're not skipping around and missing anything. All right. Now I'm going to use Descartes' rule of signs to describe the roots of f of x the number of possible negative or positive and negative. All right, so for the positive roots, I look for the sign changes here. So it starts off positive, then it's negative, then it's negative, then it's negative. So that means that there is only one change in the signs. So there's only, so for my real, my positive root is what I'm writing. Come on. So my positive real possibilities is 1. That's it. For negative, I have to look at f of negative x here. All I really care about is the sign. So if I plug in a negative x, that makes this negative, this positive, that makes this change to positive, and this stays negative. Remember, anything with an odd exponent, the sign will change. So I've got 1, 2 changes here. So for my negative real, it could be 2 or 0. All right, here is my polynomial. So I'm looking for the roots. Well, this here is at -2, 1, and 3. So it does not ask me for the x-intercepts. It asks me for the roots. So my roots are at -2, 1, and 3. Which means my factors are at x plus 2, x minus 1, and then x minus 3. But then at x minus 3, this is tangent to the graph, so I have a bounce there, which means it is a double root. All right, so now I've got to find my equation. Now, I have enough information here where I can actually find a, so I need to do that. I cannot avoid that. Here's what I can write for this so far. F of x equals some a that I don't know yet, times x plus 2 times x minus 1 times x minus 3 squared. I have this point here, so I can plug in the -1 for x. So that means that is going to give me, oh, I can plug in -1 for x and -64 for y. So -64 equals a times -1 plus 2 times -1 minus 1 times -1 minus 3 squared. So that means I have -64 equals a times, this will give me 1, this will give me a -2, this gives me -4 squared, which is 16. So then -64 equals -32a, so a equals 2. So if my equation, all I've got to do is put the 2 in here and I'm good, because it doesn't say that I have to write it in the polynomial form or factored form, so I'm going to use factored form because that's easier. So f of x equals 2 times x plus 2 times x minus 1 times x minus 3 squared. Don't forget about a. So now I'm going to solve this inequality here. Gotta look for my, actually let me just go ahead and look for my roots. So I have, let's see, I'm going to go in order here. I've got a -4, and I've got a -1, 2, and 3. Okay, this is less than or equal to, so that means that there are closed circles on my number line. So I can put -4 down here, -1, 2, and 3. Okay, and these are all closed circles. So I want to see what is happening here. If I plug in a -5, okay, plug in a -5 here, that means that -5 minus 3 is still negative. -5 is going to be squared, so it doesn't matter, it's positive. -5 plus 4 is negative. -5 minus 2 is negative. Okay, so that means altogether that is negative. If I plug in a -2, -2 minus 3 is going to be negative. I'm going to square it, so it's always be positive. -2 plus 4 will be positive. -2 and minus 2 is negative. So that right there gives me overall positive. Then here, if I plug in 0, that's going to give me negative, positive, positive, negative, which is overall positive. 2.5 would give me negative, positive, positive, positive. So that's negative overall. Then if I plug in 4, that would give me positive, 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 overall positive. So let's think about what we're looking for here. What we are looking for, it has to be less than or equal to 0, which means I'm looking for the negative part of it. So I have this. This is my negatives, and these are solid. Now I also want you to think about what that means and why, okay, because we had these two positives next to each other. Well, that was a double root right there, okay, and it was a bounce. So if I was going to draw this, let me think about my end behavior here. This is a 1, 2, 3, 4, 5th degree. So for a 5th degree polynomial that's positive leading coefficient, the end behavior looks like this. So that means it would come up, it's going to intersect the axis here. When it comes back down, it bounces here because this is a double root. And then it goes back down and back up. And again, this is where it's negative, right there. So to actually answer the question in interval notation, then we are going from negative infinity to a negative 4, and I do include that. And then from 2 to 3. I'm going to stop here so that I can let this video process, and then I'll finish it in the next one.